Ratios and proportions. Learning outcome. When you complete this chapter, you will be able to describe the concepts of ratio and proportion. Learning objectives. Here is what you will be able to do when you complete each objective. Find ratios of one quantity to another quantity. Solve word problems involving ratios and proportions. A ratio is the number of times that one number is contained in another number. For example, if the stroke of a pump is 100 millimeters and the diameter of the pump cylinder is 50 millimeters, the ratio of the stroke to the diameter is 100 to 50. A ratio can be written with the terms separated by a colon, making the above 100:50, still referred to as 100 to 50. The ratio could be left in its original figures, but reducing it to its lowest terms, in this case 2 to 1, conveys a much better idea of the comparative size of the two dimensions. In order to get a ratio between two quantities, they must be in the same kind of units, and the same scale of units. Kilograms and kilometers, or apples and colors, cannot be sensibly compared as a ratio. To express meters and millimeters as a ratio, both quantities must first be converted to meters or millimeters. Example 1. What is the ratio between a mass of 2 tons and a mass of 500 kilograms? First, the values must be converted to the same units. Either number can be converted to the other number's units. 2 tons times 1,000 kilograms per ton is 2,000 kilograms. Now, the ratio between the two numbers with the same units can be found. The ratio is 2,000 kilograms over 500 kilograms, or 4 over 1. So the answer would be 4 to 1. Example 2. What is the ratio between a measurement of 6 meters and a measurement of 120 millimeters? First, convert 6 meters to millimeters. 6 meters times 1,000 millimeters per meter is 6,000 millimeters. So the ratio is 6,000 millimeters over 120 millimeters, or 50 over 1. So the ratio is 50 to 1. Proportion. When two ratios have the same value, are equal, they are said to be in proportion. 3 is to 1 as 9 is to 3. A common way of writing proportions is by using colons between the ratio values and double colons between the two sets of equal ratios to indicate they are equal. 3 is to 1 as 9 is to 3. Application of proportion. The principle of proportion is used when there are two ratios but one of the values is unknown. When a pair of equal ratios are written with colons, the outside pairs are known as the extremes and the inner pairs as the means. The product of the means is always equal to the product of the extremes. Therefore, in the above proportion, 3 times 3 is equal to 1 times 9. From this, we get the following rules. The product of the two means divided by either extreme gives the other extreme. The product of the two extremes divided by either means gives the other means. Example 3. If 9 tons of coal cost $125, what will 4 1/4 tons cost if the cost per ton is the same? Let x equal the price of 4.25 tons of coal. The proportion is written as follows. X is to 125 as 4.25 is to 9. We know that the extremes, x and 9 multiplied together, will equal the means multiplied together, 125 and 4.25. So we get the formula x times 9 is equal to 125 times 4.25. Rewritten, that's x equals 4.25 tons times $125 over 9 tons. Working that out, we get x equal to $59.03. Example 4. Brass is a mixture of copper and zinc. How much copper must be mixed with 60 kilograms of zinc if the ratio of zinc to copper is 3 to 7? So the ratio of zinc to copper is the same as the ratio of 3 to 7. Since we know there's 60 kilograms of zinc, 60 is to the mass of copper as 3 is to 7. So 60 times 7, the two extremes, is going to be equal to copper times 3, the two means. Rewritten, that means the mass of copper is equal to 60 kilograms times 7 over 3. Copper would work out to 140 kilograms. Example 5. A certain chemical mixture should be in the ratio of 3 parts A, 5 parts B, and 2 parts C. A 15 kilogram batch is to be mixed. What quantities of A, B, and C should be used in the batch? Adding up the components, the mixture is seen to be made up of 10 parts. That's 3 parts A plus 5 parts B plus 2 parts C. So the proportion of each component is as follows. A makes up 3/10 of the chemical mixture. B makes up 5/10, or 1/2, of the chemical mixture. C makes up 2/10, or 1/5, of the chemical mixture. To find the amount of A needed in the batch, the ratio of A in 15 kilograms will be the same as the ratio of A that's normally in this chemical mixture. So, A is to 15 kilograms as 3 is to 10. Rewritten, we get A is equal to 15 kilograms times 3 over 10, or 4.5 kilograms. To find the amount of B needed in the batch, B will be equal to the 15 kilograms as 1 is to 2. B is equal to 15 kilograms times 1 over 2, or 7.5 kilograms. To find the amount of C needed in the batch, C is to 15 as 1 is to 5. So C is equal to 15 kilograms times 1 over 5, or 3 kilograms. Inverse proportion. The previous problems were examples of direct proportion. In example 3, the price increased directly as the mass increased. An increase in mass means an increase in price, and a decrease in mass means a decrease in price. In instances of inverse proportion, the opposite holds true. That is, an increase in one factor means a corresponding decrease in the other factor. The most common examples of inverse proportions are problems involving size and speed of gear wheels that are meshed together, or of pulleys that are connected together by belts. The speed of such pulleys and gear wheels are inversely proportional to their diameters. The ratio between the speeds of the gears or pulleys will be the same as the ratio between their diameters or number of teeth, but the smaller pulley or gear will run at the faster speed, and the larger pulley or gear will run at the slower speed. Example 6. A gear wheel 200 millimeters in diameter and rotating at a speed of 80 rpm drives a wheel 160 millimeters in diameter. What is the speed of the second gear? Since this is an inverse proportion, the speed of the second gear is to the speed of the first gear as the diameter of the first gear is to the diameter of the second gear. That is, the speed of the second gear is to 80 as 200 is to 160. Rewritten, we get 80 rpm times 200 millimeters over 160 millimeters. So we find out that the speed of the second gear is 100 rpm. Example 7. A supply fan is driven by an electric motor by means of V-belts. The pulley on the motor shaft is 65 millimeters in diameter and rotates at 1600 rpm. The diameter of the pulley on the fan shaft is 200 millimeters. What is the speed of the fan? Fan speed is to motor speed as the diameter of the motor pulley is to the diameter of the fan pulley. So, fan speed is to 1600 as 65 is to 200. Reworked, that gives us 1600 times 65 over 200, or a fan speed of 520 RPM. Example 8. A driving gear has 50 teeth and turns at 550 RPM. The driven gear has 80 teeth. How fast does it turn? Let x equal the speed of the 80-toothed driven gear. The driven speed is to the driver's speed, as the driver's teeth is to the driven teeth. Reworked, we get 550 RPM times 50 teeth over 80 teeth. So the driven speed is 343.75 RPM.